You open your WAEC 2025 mathematics exam, and question 1 is the first problem you encounter. The whiteboard shows the specific prompt. Write 0.0364891 in 3 significant figures and express the answer in standard form. 4 possible answers are listed below. This problem requires the simultaneous application of 2 rules, rounding to a specific degree of accuracy and correctly assigning the sign of an exponent. Grab a pen and a piece of paper. We will work through the specific steps required to reach the solution. We will divide the process into 2 phases. First, we will identify the 3 significant figures. Second, we will translate that result into scientific notation. Using this procedural sequence ensures that the final result satisfies both requirements of the prompt. Let's examine the starting number, 0.0364891. The first rule of significant figures is that leading zeros are placeholders. They indicate the scale of the number but do not count towards its significance. Consequently, we only begin counting significant figures at the first non-zero digit. Starting from the 3, we count 3 spaces to the right to isolate the segment required by the prompt: 3, 6, and 4. Identifying this starting point correctly is essential. Errors here carry through to the final conversion. It can be tempting to simply stop after the 3rd digit and remove the rest of the sequence. However, the rounding rule states that the value of the 3rd significant digit is determined by the digit immediately to its right. The 4th digit in this sequence is an 8. Since this is 5 or larger, we adjust the preceding number. Because 8 is greater than 5, the 4 becomes a 5, and the remaining digits are removed, leaving 0.0365. Rounding correctly, rather than simply truncating the number, ensures the result reflects the original value with the intended precision. To express the result in standard form, the decimal point must be repositioned to create a base number between 1 and 10. We move the decimal point 2 places to the right so that it sits immediately after the first significant figure. This creates our base number, 3.65. The direction of the decimal movement determines the sign of the exponent. Since the decimal moved exactly 2 spaces, the exponent value is -2. Combining the base and the exponent gives us the final form, 3.65 times 10 to the power of -2. Linking the number of spaces moved directly to the exponent value provides a consistent method for standard form conversion. Compare our derived answer, 3.65 times 10 to the -2, against the exam options. Option C is the result of truncation instead of rounding, so we eliminate it. Option A has a positive exponent, which our decimal rule avoids. Option B uses an incorrect base number of 2.64, which doesn't appear in our calculation. This leaves option D, which matches our result exactly. We have successfully moved from a raw decimal to a rounded value, and finally to the correct standard form representation. Consistent application of mathematical rules is the best way to resolve multi-step problems on standardized exams.